and gentlemen, that's not what I wanted to do. That's what I wanted to do. All right, ladies and gentlemen, this class recording has started. So, yesterday, we started in on the last part of this unit dealing with heat and thermal energy. And yesterday, we introduced three terms that all kind of sound similar: thermal energy, heat, and temperature, but they are all different. So to get us started for today, I would like you to take 30 seconds, talk to the person next to you about the similarities and differences between heat, temperature, thermal energy. Go. All right.
That was good.
So first, let's discuss the similarity between all three of them. What do all three of them deal with in some way?
Work.
Did you just get down the line, or? All right. All three of them deal with movement in some way. Specifically, the movement of what? Particles, and those particles could be atoms or molecules, depending on what we're talking about. So let's start with the big picture one, thermal energy, right? Thermal energy takes into account what? The total amount of motion, right? So how much is each particle moving, but then also how many particles are there, right? The total amount of energy that we got there. Temperature. Temperature takes into account what? The average of each individual one, right? So we could have a very small sample, but those particles could be moving very quickly and it has a high temperature, right? And then the last one, if you notice on your outline for today, the last one is heat, which is actually Roman numeral number 1 on today's outline. So how did we define heat yesterday? Transfer of thermal energy because of temperature difference, right? So you'll notice that that's the first line on your outline, right? Transfer, so heat we define as the transfer of thermal energy due to a temperature difference. The temperature difference is important because which way does the heat flow? Hot to cold, right? Spontaneously, heat flows from things that have a high temperature to things that have a low temperature. And that is Roman numeral number 1, letter B. Okay? Something stuck to the bottom of my shoe. High temperature? Or low temperature? All right, good on that for starters.
Yeah.
So as far as today is concerned, we want to talk about, well, how does that happen? And we'll find that there are three ways that we can get heat, energy, to flow from high temperature things to low temperature things. So we'll start off with the simplest one, and that's conduction. Conduction. We've talked about things conducting before in the in the context of electricity. Kind of the same thing, not exactly though. So first, transfer of thermal energy with no transfer of matter. And in order for that to happen, there has to be contact between whatever we are passing this energy between. So conduction depends on contact. All right, first let's talk about relating it back to what we talked about earlier in this unit, okay? On your outline, you'll notice that there's a little statement there. It says, use the principle to explain why conduction happens more slowly in gases than it does in liquids and solids. Well, what did we say the material key to conduction is? Touching, right? And we learned about gases are all spread out, right? There's a lot of space in between them, the individual particles. Yes, they move quickly, but there is a lot of space between them. So, how often do they come in contact with each other? Particles of a gas, how often do they come in contact with each other? Every once in a while. Not real often. Especially when compared to solids, right? The picture on the left representing the particles in a solid, picture in the middle a liquid, picture on the right gas. Okay? So, why does conduction happen more slowly in gases? Because those particles are so spread out, and those collisions happen less frequently, and therefore it does not conduct energy very well. All right. Good there. There's something written down that summarizes that. I mean, record. Do whatever you want. You have a test next Friday. You're ready for the test.
I'm not obviously.
That's fine. All right.
Oh my God.
Yeah, we're recording right now.
That's true. We already beat the coding. All right, let's talk about the next thing we talk about is what type of materials do conduct well and what type of materials don't conduct so well. So materials that do conduct well we call conductors, right? A material that conducts thermal energy well. Based on our discussion from a couple seconds ago, you would probably make an educated guess that conductors might be what state of matter? Solids. Although we'll talk in a second, that's not the only thing that determines whether something's a good conductor or not, right? But generally, things that are conductors are good solids. Good conductors are solids. For example, the metal part on a pan on the stove, right? We want that material the heat to flow from the burner into the food. So we need something that conducts that heat very well. The next example on there, right? Floor tiles. That starts getting us into analyzing stuff that happens to us all the time that maybe we don't quite understand. So a couple months ago, right, we were complaining about how cold it was, right? And there were a couple mornings when it was like minus 15, minus 10, and we still had to go to school, right? You know, that was good time, right? Good time, minus 15. Yeah. So we haven't got there yet. All right, so let's go back to that early morning on or early, 6, 7 a.m. when it's minus 20 outside, but you still have to go to school, right? So you drag yourself out of your warm, cozy bed, right? You walk down the hallway like this, right? Okay. But then you get woken up real quickly because, right? You take that first step into the bathroom, right? Whew, right? Yeah. So what? Ooh, yeah, that's how. Yeah, that hurts too. One thing that it helps me out a little bit is that I'll like when I wake up, I like read my phone a little bit and kind of So when I go into the bathroom and turn on my light, the light in the bathroom, it's not as bad. It really is kind of
Well, I
bad.
sleep with the lights on. Yeah, that's like a lot right now, but yeah. So it doesn't really happen to me that much.
Yeah, I can see that.
But you should probably take your contacts. I can't say that she doesn't take her contacts out either. She does the same contacts as she loves.
I had a friend who used to do that.
There's the surgery, they're the 2-week ones.
Yeah. So,
No, mine are the month one.
so.
Yeah, but still.
I had a friend who used to do that, just sleep with his contact all the time. So
Yeah.
he's fine now.
My dad like spits on them and like.
I mean, his eyes still suck, but whatever. So. All right. So.
Did you hear what she said?
No.
Her dad spits on them.
I mean, there's really nothing different between this and this. I mean, like tears and spit, they're kind of the same thing.
Yeah. No, actually, if you get your hand that's supposed to solution, but you don't have solution, then you actually have contact. Like just lick your contact. It's a lot better than putting it in the water because water is so.
Yeah. All right. So now that we've had that discussion, right? Let's talk about the cold bathroom floor. So you step into the bathroom, and you're like, wow, that floor is cold. But if we think about it, your carpet that's in the hallway and the floor in the bathroom should be the same temperature. They've been sitting in your house all night long. Exactly the same house. So let's talk about why one feels colder than the other one. First, in comparison to you, both your carpet and your tile floor in your bathroom are cold, right? If you set the thermostat in your house in the evening time, you guys don't probably get to set the thermostat, but whatever. If the thermostat is set for, let's say, 65 degrees. Your mom doesn't like the thermostat.
I'm so sorry.
When people came to Ohio, they didn't have thermostats, and we don't need one either.
She's just like, no, the house is fine. Just open the windows. That's not mine. In the winter? Yeah. I think my window open in the winter. Why?
Letting the homeless people.
That's in my dorm room in college. I had to do that. Like it was like an 8x10 dorm room, but it had like a single.
Okay, well,
like,
that's Alex's living situation.
yeah.
So
So
that's a problem.
well, that was my living situation for 4 years. So yeah.
That's her life.
So that was my life for 4 years too.
Yeah, give some tips.
So, and then I didn't have. Then there was no air conditioning in the summer. That's
You have something.
you had to like. There was no air conditioning. I had to sleep with like a box fan just at the end of my bed on high. Just like that was. Yeah, it stinks.
Got it already. It was like a
So, the basement should be cool though. The basement should be cool. What?
My dog.
Yeah, it's nice and cool down there. All right. So, when your foot makes contact with something that's colder than it, heat flows out of it, right? Hot to cold. So if you're warmer than the floor, heat flows out of you and into the floor. But the carpet and the tile in the bathroom are exactly the same temperature. But clearly, one feels more cold than the other one. Sorry, one feels colder than the other one. I should at least use proper grammar, right? The heat is coming out of you faster in the bathroom than it does in the carpet in the hallway, because the tile is a conductor. It sucks heat out of you faster than the carpet. All right? That makes sense. So, on the other side, that makes carpet an insulator. Don't worry, we'll get to that. So, okay. Yeah, I realized that we skipped one thing, heat. That's okay, right? So, you probably can figure out that an insulator is something that conducts thermal energy poorly. The energy doesn't flow out of you as quickly when you're standing on the carpet because carpet doesn't conduct energy very well. Going back to our states of matter discussion from a couple minutes ago, it would make sense that insulators are probably what state of matter?
Gas.
Insulators, gases would make the best insulators because they're real far apart, particles are real far apart, collisions don't happen that often, doesn't conduct energy as well. Carpet is not a gas, right? Neither is your big comforter on your bed, you know, like one's like this thick, right? Okay? That's not a gas either. But neither is the pink fluffy insulation in your walls. However, if you look closely at the structure of all of those, right? Your big comforter is made out of cotton. But what's inside of that cotton? A bunch of air pockets, right? Styrofoam. Styrofoam is full of air, right? That's why it doesn't let energy flow out of it, okay? While certain things may be classified as insulators, certain solid objects, right? Like a Polar Pop at Circle K or something like that, right? If you look at their structure, they will probably have a lot of air incorporated into them, right? In the wintertime, in order to keep warm, how are you supposed to dress? You're supposed to dress in layers, right? Why? Because in between your thermal and your sweater and your sweatshirt and your jacket, in between each one of those is what? Air. A layer of air, right? And that keeps the energy from getting out of you, right? If we go back to the Magic School Bus episode that we watched last week, right? When they were trying to prevent their heat loss from doing those, they were like jumping jack, like squats, I don't know, whatever they were doing. But in order to prevent that heat from being lost, they built an igloo around the bus, right? Snow is cold, but what does snow have mixed in with it? A bunch of air, right? On those Discovery Channel shows, when they send somebody out in the woods with like, you know, a pair of scissors and a nail file, and they're like, you know, survive for a week. Yeah. It's a Survivor Man, or, you know, Man versus Wild, or, you know, whatever. Let's not go there. So, yeah, it's not cheating. But, right, in the cold, right, at night, you can bury yourself in the snow, right? You should keep your head out, right? But if you bury yourself in the snow, that actually keeps you warm. Yeah, the snow itself is cold, but it prevents that heat loss from you to the outside air because it has all that air mixed into it, right? Yeah. Here. Here's an example, right? Another example, something that we hopefully don't have to deal with for a couple other months, but icicles on your house. Okay? Get icicles on your house? Right? Yeah. You only get icicles if you have bad insulation, but only if it has to do what first?
Rain.
Rain won't make it get icicles, so it has to snow. Because that snow on top of your roof acts as an insulator. If there's no snow on your roof, you won't get icicles. But what happens is the energy that comes out of your roof, right? And you have insulation to try and prevent that from happening. But if you have bad insulation, or if sometimes it just happens over time, some energy leaks out of your roof. But there's a big insulating layer of snow on top of it. So that energy then can't get out into the outside air. But it does hit that snow. And what does that energy do to that snow? It melts it. Even though it's really cold outside, if it's protected by a big layer of snow, that snow underneath, real close to your roof, melts. And when it melts, it rolls down the roof into your gutter. But your gutter doesn't have that snow insulation. So what happens to that water when it gets into your gutter? It freezes. And now we have icicles. All right? And if your house is really poorly insulated, that can continue to happen, and we end up with something called an ice dam on top of your house. Have you ever seen, like, when it happens, that's what you need to say. Because, have you ever seen some of those houses where they have a ton of icicles, but there's also like that foot of ice that just piles up like right in the front? If that continues to happen, right, it starts getting underneath your shingles of your roof. And then, no, it's not good at all. And then it starts melting once it gets inside your attic, and that's not good. So.
That's what happened to me. Once I was home alone, and my wall just poured out water, and I freaked out.
Was it wintertime?
Yeah, it was so scary.
Yeah.
I didn't know what to do, so I just put a towel on the wall and just kept watching TV.
It's kind of like
My parents are so mad that I didn't call them. I just threw it off.
It's kind of like if somebody stabs you. It's like, just put a Band-Aid on it. You okay? So, yeah, if that happens again, call your parents.
Okay.
So, okay.
We're getting a new roof soon.
Good,
hopefully.
good. You probably need one of those.
Well, they never do it. They always say they are, but it never
So,
actually happens.
I mean, now, summertime.
True.
All right, so, insulators. Something to keep in mind with insulators. Generally, they are going to have, now one thing that all those things have in common, right? There's a lot of air incorporation in them. There's a lot of gas incorporation, and that prevents that loss of heat from occurring too quickly. Doesn't totally stop it, but it does prevent it from happening quickly. Okay? Underneath conductors and insulators, letter B, we skipped over 2 parts there. I'm going to save that until tomorrow because that discussion of that topic is better suited for tomorrow. We'll come back and fill that in. So there are 2 spots that are empty. We'll come back and fill it. Okay. All right, good there. Okay. Let's talk about another kind of heat transfer, and that's convection. Some of you probably are familiar with convection before because you have a convection oven or a convection current. Okay, so let's talk about what convection is. All right, transfer of thermal energy when particles of a fluid, and when we say fluid, that could be liquid or it could be a gas, move from one place to another. Transfer of thermal energy when particles of a fluid could be liquid or it could be gas, move from one place to another. So in this case here, right? Say again? Fluid could be a liquid or a gas, either one of those, because they don't have a definite shape. You know what I'm saying? That's something that's fluid doesn't have a definite shape. Solids aren't fluids because they have that definite shape. But liquids or liquids or gases could fall into this category. Okay. All right, so let's talk about yesterday. So 2 things yesterday. It was pretty cold yesterday, right? Especially like we were out there late afternoon, early evening. I cut my grass a little bit. So yeah.
But you just
now,
cut it a little bit, did you finish?
Oh, I cut the front because and it was already like, it was like 7:20 and I was like, the Cavs game started 20 minutes ago and so I don't want to cut the back anymore. So I gotta do that today. So anyway,
I'll actually do it for you.
it's okay. Thanks. I appreciate it. So. All right, but yesterday it was windy and that makes it feel even colder because, right? Air temperature 60. Body temperature, 98 Fahrenheit, approximately. Right? That means which way is heat flowing? Out of you into the air, which is fine. The air around you then gets warmer because it's picking up energy. Okay? But if it's windy, right, that warm air that's surrounding you, that got warmed up because it was next to you, it gets blown away and it gets replaced by what? Cold air, right? If you go swimming in a swimming pool, right, you jump in originally, right, and it's kind of cold, yeah? But after a while, you get used to it, right? Not that the pool warms up to body temperature, but the difference in temperature isn't as great. However, if you go swimming in the ocean, right, you never really get used to it. If you go like the ocean, yeah, right. But if you go, yeah, like if you go like in the Pacific Ocean or something like that, right? When you go swimming in that ocean, when? Anyway, let's talk. But from a convection standpoint, right? Yes, in a swimming pool, the water around you is moving, but it's somewhat limited in where it can go, right? In the ocean, those waves keep coming, and any water that was next to you that warmed up gets replaced by that wave that's cold, right? And now you got that cold water surrounding you again, okay? So that's one situation where it sort of works against us, but there's times when it works for us. For instance, not that, you know, this will happen or I don't know, maybe it will, but it's not really a spring, summer kind of food, but your mom ever make beef stew for you in the wintertime, right? Like in the crock pot. The crock pot, you know what? See, sometimes they smell like it's kind of a good and a bad, because like, one, it smells really, it usually makes the house smell good, but I think it does, you know. But it, like, you have to think about, oh, I'm going to be hungry 8 hours from now, so I better start cooking now. Like, anyway. But so, yeah, you know, yeah, you can throw things in there, turn it on, you know. I know, I got it. No, it's convenient, but it just, like, you know. Anyway. So.
Nice.
I usually don't use the crock pot, but I cook. I do a decent amount of cooking at my house. So anyway, but so you have your beef stew, and you got your beef, and you got the gravy, and then you got the carrots, and then you got potatoes, right? So everything's going good. Onions too, right? Some people don't like the onions. Like mushrooms. Some people like the mushrooms. I don't like mushrooms. But anyway, so you're eating your beef stew, and everything's all good until you bite into a potato. Because the potatoes are always like 800 degrees warmer than everything else. Oh, yeah. You know? So like you bite, like everything's going good until you bite that potato and you're like, oh, did I just eat lava? Oh no, it's just a potato.
You're like, I can't feel my tongue.
Yeah, I just can't feel my tongue because it's burned off of my face. You know? So, anyway, so your response to that is then what?
Ow.
Actually, I better call in some convection for this job, right? So when your potato's hot, what do?
You drink water.
No.
You blow on it.
You make their face.
That face, yeah.
Pass it around I'm so glad this is recording.
Yeah, it's good. It's good. Alyssa's gonna like this. So.
Oh, Alyssa. Hi, Alyssa. Your eyes feeling good.
All right, so
Feel better, Liz.
blowing on your food to cool it down. Your potato, temperature lava. Air temperature less than lava, right? Air or heat is flowing out of your potato and into the air. If you blow on it, that hot air that was surrounding the potato is now gone and you replace it with cooler air, right? Convection is that movement of material to transfer that energy, right? A convection oven works basically the same way, but now we're surrounding the things in the oven with hot air, right? If you're cooking a pizza in the oven, You need to get heat into the pizza. So you warm up the oven and you make the air hot. And so heat flows into the pizza from the air. But if you have a convection oven that has a fan, right, you keep moving that air around and put hot air in contact with your pizza constantly, right? So convection depends on the movement of the fluid. Okay? Good there. All right. Let's call it a wrap there for today. Didn't get as far as we did yesterday, buddy. Good job. But so tomorrow we'll pick up with radiation and then hopefully get into calorimetry.
What do you